the first thing you need to do, and we're going to use this data, you need to guess how many wooden beads are in this jar. I'm going to give you 1 minute to come up with your guess. Don't shout it out. Don't share it. We're going to collect the information in a moment. So to expedite this process of you guys need to write down everybody's guesses. I'm also going to write it down where you can see it. We're going to start with Lynn, and we're going to zigzag down the rows here, okay? So just like when I say okay, next person. When I say okay, next person. So Lynn's starting us off with her guess. 78. Okay. 62. Okay. 62. Okay. 56. Okay.
58. 53.
Okay.
57.
Okay.
43.
Okay.
47.
All right.
Rylan.
Bye-bye.
47.
Okay. All right. Okay.
It's not your
Oh!
Hey.
53.
Okay.
41.
Okay.
Huh. 84.5.
Okay.
Do that. 32. You can't do that.
Okay.
37.
Okay. Lulu.
62.
60 what?
2.
62.
67.
Okay.
64.
Okay.
65.
And we already got Liam's.
We already got you.
Okay. So here's all of our guesses. Not actually a huge range, but what we're going to do now is I'm going to tell you how many are in there. Watch this. Here's the number.
50.
No, I'm not done yet.
50.
Nah, you definitely put 50 in there.
75. Actually, the real answer is 0. They're plastic.
What?
I said wooden. No, I'm joking. I'm there. So there's 75 in there. Here's what you're going to work on next. Today's lesson is about absolute value and absolute value functions. We're going to find the absolute guessing error. So what the absolute guessing error means is how far away we are from the guess. If we're talking distance, are we ever negative for distance? If I take 2 steps to the left, how many steps I take? If I take 2 steps to the right, how many steps I take? Take it back now, y'all. Now, see? Okay. So, you guys know. So, distance is positive. So we're going to roll through like 4 of these together, and then you're going to finish this up. So, 78 is how far away from 75? 3. 62 is 13 away. 63, 12 away. Let's keep finding these distances away. We're going to do 2 more together. 56. So what I like to do is I like to add 9 to it to get to 65 and then 10 more to get to 75. 58, 2 more closer. 17. 53, I'm going to do 1 more. Just 22 away. So you're going to continue to find how far away they are from the guess from the actual. Notice, even when I guessed higher or if I guessed lower, did I ever get a negative distance away? Not even once. All right, get after it. Okay, so after we find all the guesses and how far away the guesses are from the actual, the reason we have this table is the guesses are the input and the distance away is the output. Okay, so now we're going to go to our graph and we're going to graph all these ordered pairs. And we're just going to look for like, something's going to speak to us when we see it, like the shape, the flow. Something's going to speak to us and we're going to look for that. So let's establish what scale we need for our x-axis. We need to go as high as 90 maybe. So I'm going to go, no, I'm going to go by 5s, but because things are tight, I'm going to label every 2 as 10. So 10, 20, 30, 40, 50, 60, 70, 80, 90. So again, it's by 5s, but because it's tight, especially on the iPad writing, I went by every other as 10s, which is every single one is 5s. And then the highest we are off, 43. So we can go by 2s, but I still might go every other. So I might go every other but by 4s.
I did it so wrong.
4,
Yeah, you did.
8, 12, 16, 20, 24, 28, 32, 36, 40. That doesn't look like 40. 44. I think that's high enough. So next, all we're going to do is plot or ordered pairs. I would not suggest watching me do it. It's not going to be faster than you looking at an ordered pair and plot. Like, seeing where I put it doesn't help you put it in the right spot because you have to be precise, right? So 78, 3. We're going to go over to 78, up to 3. Boom. Just put a dot there. So it's going to take a little time. But watching me do it again, I don't think will help you go faster. 62, 13. It's right there. 63, 12. It's right there. And so on. All right, so we need to graph all these points now. So is there anybody that could describe the shape we're getting from our input and outputs here? Greta?
It looks like a backwards check.
I see check mark. What do you think what do you think it looked like if I had more guesses above the answer? Like right now, a lot of the guesses are lower than the answer.
There'd be more of like a bigger V.
Are you guys seeing this line of symmetry here?
Yeah. It's just like you could just flip it.
Well, here's why. If I'm 1 over, how far away am I? I'm 1 away. If I'm 1 under, how far away am I? 1 on, which is both 1 for output, right? If I'm 10 away, if I'm 10 too big, okay, so 85. If I'm 85, 10, guess what else? Guess what else is 10 away? 65. So you end up getting this shape. Uh-oh. So this is not continuous. I'm just drawing this for the visual. You end up getting this shape. If it was like all the guesses of whole numbers. Why wouldn't it be continuous though?
Because not all the guesses are good.
Yeah, we shouldn't have decimals and fractions of beads, right? In this context, this is just a visual to see the function. And are you guys also seeing, if we had some higher guesses, they'd be rolling through there, okay? Everybody seeing that? So again, the reason all of our outputs are positive and there's a mirrored output is because we're talking distance away from the guess. Because this is a special type of function called, everybody's going to write this at the top, an absolute value function. An absolute value function. Yeah, in a functions unit last year, you identified how different functions looked. And hopefully you remember, the V was an absolute value function. We're going to do a little more with it this year. Now, just for practice, this isn't even in today's lesson, but I want to practice it. We're going to practice writing the function. Okay?
Great.
Yeah, it's actually not bad if you just so f of x equals. So, what operation did we end up doing every single time to get the answer?
Plus.
Did we add or subtract? We subtract to see a difference. So check it out. Absolute value of x minus 75. That is the function. No, because that's a great question. If I guessed lower than 75 and I subtract, I would have a negative number. So a great thing to do once you get your function is to test it out with some known answers. So let's go 5 over 75, which is what?
80.
So without even using the function, 80 is how far away from 75? 5. Well, let's put 80 into the function. What's 80 minus 75?
5.
And what's the absolute value of 5? 5. Let's put the other that's 5 away. So if 80 is 5 away, so is 70. Let's put 70 into the function. 70 minus 75 is?
5.
No, 70 minus is negative 5, but the absolute value of negative 5 is 5. So this function gives us the right output every time. The most common wrong thing I will see on the quiz is this. I'm going to write it in red because red will mean no. The most common wrong thing I see on the quiz is this. And the reason I think I see this is 75 to the right plus 75 on the x or something. Don't do this. A great way to catch yourself is to substitute in an answer. If you know 80 is 5 away, if I put 80 into here, I do not get 5. Correct? Are you guys seeing that?
Yeah.
Okay? So a great thing to do is to check. Okay? All right. I think I feel good about all that. How you guys feeling good?
I'm feeling excited.
Except I made a mistake.
Bro.
I
To redo the whole.
hope you guys will forgive me. But there's actually 65 beads in the jar.
Did it to make Ben feel
Did you just realize that?
So, yeah, we got to redo it. Now, yep, there's actually 65.
This is all a part of his scheme.
The back of your paper, good news is the back of your paper has another graph, and I didn't plan that at all. So, now, it might seem like, dang, that's some work. It is. So, let's do this. By the way, work's not bad. Nobody's going to start sweating from graphing things, okay? But maybe let's do those and let's do those. We'll cut. Wait, let's do even less. The highlighted ones for inputs instead of all of them, okay?
We just do like the top.
The highlighted inputs for all of them instead of all of them. Okay, so I need you to find how far these guesses are from, I'm sorry, it's actually 65, not 75. How far are these away? Now, the real reason that we're looking at this is to see how it's different. We're going to compare what happens when we change the number. Yeah, the 57's in there. All right. Find the absolute guessing errors, friends. So let's chat about what we see. What shape do we still have? Still have a V shape, right? Each output has 2 inputs. Is that a problem for a function?
Yeah.
Each output has 2
Oh,
inputs.
no.
Does each input have 1 output?
Yeah.
Still a function. That's why it's an absolute value function. James, you want to give a shot at the function?
F of x
Yep.
equals x minus 65.
And really, how would you say our graph shifted? Did it shift the whole thing to the right or to the left? To the left by how many?
10.
Yeah, to the left by 10. Because we're finding the distance away from 65 this time instead of 75. So let's say it was actually 80. From here, 15, right? It's not the... Oh, another mistake. No, not another mistake. Okay, so the big ideas from today is we can write a function and do the shift left or right of the origin right there. Okay? Absolute value functions make which shape? A V. Okay? And it's called an absolute value function. Cool? I think it's pretty fun. That's the 8th one of these I've done today. 8th graph I've made. Yeah, that's why I'm so sweaty. Yeah. Okay, so we have a lesson summary, and that's it.